Hey, we spoke too soon. How's it going? This morning just kicked off our brand new daily vlog series. The goal is to get 10-minute length videos, not 3-hour videos. And yeah, I'm pleasantly surprised because I just rewatched that video and I was like, what did I talk about yesterday? And I was like, well, last week flopped. Last week I was studying number theory. I was working on building the just natural arithmetic system from the piano axioms using lean, using like the new proof assisted mathematics systems. And I was like, well, that flopped, but that's okay because I'm doing this stuff for myself. And hey, just last night, one of those videos really started popping off. So I successfully now have 2,000 view videos, and I'm very proud of that. For a brand new channel that started last month, I think that's pretty cool. We're at 2 already. From my experience with my other classical music channel, it's not that easy to hit 1,000. So, hey, that's cool. So that video was the older format, but I think that there's still something in the basic idea of like shorter videos, because that one was 28 minutes and it was just focused on one problem. I was just solving one lean problem. I was proving that a plus b quantity squared equals a squared plus b squared plus 2ab. Super simple fact, everybody learns that, but you're just told that that's true in elementary school, or you learn it through the distributive property. But if you want to get very formal, you need to prove that everything is just a successor of 0. 0 is the only number, and then you have something else called a successor of a number. So this is like formalization of math into axioms. What can we prove is true, as opposed to believing it because it seems to work. That is, to me, what real math is. It is formal arguments of formal logic. Let's all just agree to assume the same thing here. We have the same starting point so that we're not just endlessly arguing definitions and semantics. Let's all agree on this starting point, and then from a common grounds of agreeance, of assumptions, what can we build out of that? It is honestly just like philosophy. It is philosophy. It is so... like pure math as a field of logic is, to me, a form of philosophy. And you might, if you're more interested in that idea, you might be interested in a video interview that I did a couple of weeks ago with Leo Lectures. And we really talked about, is math an art or is math a science? And the real answer is both. It is useful to solve physics problems, absolutely, and that is the motivation. It is incredibly useful to count how many acorns you have and to put them in a nice grid of, of acorns. And like, oh my gosh, why can't I find a rectangle that fits the number 7? I have 7 acorns. Why can't I find one? Maybe there are some numbers where the only rectangle is like a long rectangle. So there is math in the real world. There is math in nature. But then there's this other kind of math that we say, okay, let's keep stripping back until kind of like Descartes, like I think, therefore I am. Like, I can't doubt that this thing is true. I have a hard time believing why 2 parallel lines cannot cross. Let's just assume that that's true. And then you build math after that. And then like to me it's like the game is, let's invent math based on a set of commonly created, commonly agreed on axioms. Anyways, so I'm ranting again. This week we are kicking off a 10-minute series. So this is the beginning of today's live stream. I'm just going to hang out, practice math. I'm just going to study math with y'all. What did we do yesterday? Yesterday, I've started trying to fill in my major gap in probability. So a Columbia math PhD friend, Jay, thanks Jay, friend of the channel, and another friend of the channel, Ben, they both pointed out that probability is a huge gap for me, especially if I'm considering trying to learn math for machine learning. I'm like, I love linear algebra. I graded linear algebra homework sets a long time ago in college. Therefore I can do machine learning. And they're like, you realize that probability is just as important, right? I'm like, but that's boring and I've never studied it. And they're like, well, you got to study it if you want to maybe go in that direction. I don't know what I'm doing. I got affected by the tech layoffs, and now it's like, I think I might want to go to grad school. But do I go to grad school in math or do I go to grad school in computer science? So I've worked as a software engineer for the last 10 years. And to me, I'm really interested in the cross-section, that like intersection between the two. I'm interested in applying artificial intelligence to modern mathematics, like to the modern formalization efforts. Speaking of formalization, with lean. And it ties really well with my love of test-driven development and automation in software. In software, you write a secondary program that proves that your first program is correct. I'm not ready yet. I'm not ready yet to reach out and email Kevin Buzzard, but we're getting back in shape. I'm re-sharpening my math skills, and I genuinely really want to study algebraic number theory. I want to understand the proof of Fermat's last theorem, ideally as a hobbyist. I think that would be such a badass goal of this channel. If I could help formalize Fermat's last theorem and understand it, truly understand it as a hobbyist, that sounds pretty cool, I think. All right, so this one might end up being a 15-minute, but that's okay, right? 15 minutes is fine, right? What we did yesterday, I think, is controversial. People kind of wince when I tell them that this is how I like to study math. I like to study math with index cards, okay? So what do you think? Because I think that there's an argument here. You can shuffle them, you can number them, and you can sort them again. If you're like, I used to take lecture notes in LaTeX in class, and I was so proud of how I had all my key bindings set up, and I was using Vim, and I had an HTC Evo with a kickstand and a Bluetooth keyboard, and I would take lecture notes. But nowadays, I just believe really strongly in the value of handwriting. I really believe in the muscle memory, in the benefits of muscle memory of writing something down. So that's to say, nowadays I prefer paper. If I'm going to write things on paper, my preferred old, long-lasting style is Moleskine, tiny Moleskine notebooks. These like pocket notebooks, you can literally stick it in a pocket. They're not cheap, but if it inspires you to do math a little bit more because because it's nice, because it feels nice, then it pays itself off very quickly, is my argument. Can't argue that for everything, but still. But yeah, like, I developed this style in the pandemic when I audited a graduate algebra class based on Serge Lang's algebra book. And that class was above my head. I was not ready even to just audit that class. Like, I could kind of follow along. Like, I was at the level of dumb and foot, but I was rusty. I was quite rusty at math. So I could follow along, and I was like, I can't solve these problems, but I can write them down. Like, I don't care who you are. I don't care what your math level is. If you dream of studying for Mall's last theorem, you can write down the proof. You can copy it by hand if you want, and you're not going to understand it all. You're not going to understand any of it. But I think that you can learn that way. And I think that that's very controversial. I think that's super controversial, but I believe in muscle memory, especially after the last 10 years really learning classical guitar and classical music deeply. Sometimes you just gotta woodshed. Sometimes you just gotta practice a scale and do it 20 times in a row. Sometimes you need to like set a counter and be like, I want it flawless 20 times in a row. I'm not leaving this chair until it's done. Sometimes you just do muscle memory. Sometimes you work very, very slowly, and you trust that over time your theory and your knowledge is going to catch up to your muscle memory, and that the two kind of meet in the middle. This also came from me watching my wife studying for medical exams, and just seeing how absolutely amazing these shared Anki decks that medical students have created to share with one another. Like, she had this humongous tattered book, the USMLE study guide, first aid for the USMLE, but then she would also use Anki just like all the time, like a machine, and just get through like hundreds of cards a day or something. And I would be like, dang, these are cool formats of cards. I've never seen these methods of flashcards. Like, I mean, this is kind of straightforward, but like when I was reading probability yesterday, back to probability, I would just reframe things in my own words. And even something like this, PRML, so I'm starting probability, or pattern recognition and machine learning by Bishop, recommended by Jay, thank you very much. Because blank in figure 110 is the blank of the blank, in each blank of that blank we have CI equals box, and therefore that equals that, which is the... I remember that this last one is the sum rule. I could sort of write down these summation formulas, but one of them is the addition of something else. Because the number of instances in column I is the number of instances in each cell of that column, we have this, which is the sum rule. I think that this kind of method can really work. Like, I think it can really, really work. And one proof of that, I think, is that to get into Google, which is notorious for being the hardest data structures and algorithms interview, it's notorious for that. I mean, I've studied algorithms in the past, and I was like, I don't want to cram LeetCode anymore. What I did, I crammed for a weekend, the weekend before my real Google interview. I got a LeetCode Pro subscription. It's the one and only time I've ever used LeetCode. Got a LeetCode Pro subscription. I took a screenshot of the question statement and a screenshot of the answer, and I did that for the top 50 or top 100 questions, like equal on easy, medium, and hard. And then for a weekend, I just drilled with Anki. And when I was at the grocery store or walking around, I would just literally be memorizing. And I'd be like, oh yeah, okay, there's the general strategy. Like, I know the general strategy of how to solve that problem. I don't have to write the actual code of the thing. But I know that if I see this type of problem, I apply this type of strategy. And whenever I wanted to, I could fork a card. You just duplicate a card, create another one that's just like a remix of the same idea. So like, I took some on PRML, and hey, Keanu, dude, I'll respond more in a moment, but that's super cool to hear that you have this book. You have PRML. It's great so far. I really like it. So this is the same card, but it's just in a different format. Sum rule. What is the sum rule? It's this, and you just like remix and keep creating variations of the same cards again and again. I think that it works really well. Like, I saw that from my wife's studying of medical school. So what did we do yesterday? We wrote down a couple of facts about probability from the theory, and I understood that. And then I took a breadth first approach on Norris. So I'm mixing different books, and I wrote down the first exercise. If you want to work these problems, these are great problems. Apparently they're mixed up. But I just wrote down the problem statements of the first exercise from every section. I guess I was doing it backwards. Definition and basic properties, blah, blah, blah. First exercise of section 2, definition and basic properties. First exercise of section 2, class structure. Like, literally just writing down the titles and getting that into my muscle memory and seeing that this same example pops up again and again, and he keeps saying, prove statements A, B, C. Like, I know that something called the ergodic theorem can be used, and then that transience matrix is used in 3 different sections, invariant distributions. Like, I don't really understand it. Obviously, I haven't solved these problems yet, but I have some level of like a roadmap idea of what this book is going to be about, and like the types of theorems and the types of questions that are asked. So I think that's what we're going to be doing today again. But I want to write down more probability problems, which are actually at my level at the moment. So cheers. Thank you for watching. It looks like we're at about 15 minutes. And I'll see you tomorrow. Cool. So now I'm just going to hang out, and we're just going to study math. And tomorrow morning, I'm going to clip this part and upload it as my daily vlog. So cheers. Cheers, y'all. Whew.